Okay, so most kids are started on this, our first practice problem for today. And anybody that's absent today, I did announce that I'm allowing kids tomorrow during class. If you wish, you can, in the last part of our class, take a top 20 over again in class. So if you're one of the kids that's homesick today, study for your top 20, and you could take it tomorrow. It's right before conferences. It'd be really smart to boost your top 20 right before conferences. Okay, so that's the problem so far, but now here's the rest of the problem. Minus, and some smart kid's going to remember what we did. What's next? F of x plus h minus, yes? F of x. And then what was the new thing for now this chapter? All over h, yes. Now there's the rest of the problem. If you already started with x plus h, that was the way to start it. I said to walk to Patagonia, you just have to take one step at a time. So your first step is put that in the function. Your next step is to subtract the function, and be careful because it wants parentheses. Otherwise, you're only subtracting the first term. And then when you divide by h, a lot of things cancel. Pausing. This shouldn't be too hard because the only thing that's really new over our last test is this divided by h part. Other than that, you did this before. So, let's see. You go 3, and then x plus h squared minus 2x plus h. And then you subtract f of x, which you need parentheses for. Otherwise, you might forget to distribute and subtract both parts. So it's subtracting negative 2x, which will, of course, mean you'll add 2x at the end. And then it's all over h. Now, we just want to do one little thing at a time. I personally like to do this part next. X squared plus 2xh, or hx, plus h squared. And I'm putting that above this because that's the same as that. And then it's 3 times all of those things. So now I better not try to do too much at once. 3x squared plus 6xh plus 3h squared minus 2x minus 2h minus 3x squared plus 2x. And my pro tip in the past has been, if something doesn't cancel on the top, if you don't have a lot of things canceling, then you're probably doing something wrong. And so here's minus 3x squared, and here's plus 3x squared. Sweet, they cancel. Here is plus 2x, here is minus 2x, they cancel. And all the other things have h in them, which is cool, because then when I divide by h, they'll all cut down a notch. They won't have as many h's in them. So I'm going to move this to the front, and I'm going to say 3h. I'm cutting out an x or h right now, because I'm dividing by everything by h. Plus 6x, and it would have had an h, but again, it canceled with this h on the bottom here. Minus 2. Raise your hand if you had that one right. Okay, awesome. If you didn't, look at it for a moment. Try to find your mistake. Any questions? Okay, if I give you two functions, f of x is 3x where x is greater than 2. And notice I gave you a domain. And now there's g of x, where it's square root of x minus 3. That one you should be able to figure out the domain all by yourself. Then I could tell you to add them, subtract them, multiply them, or divide them. One of the things that I'm going to ask you to do is know the difference between this. If I say fg of x, that's totally different than fog of x. That does not mean times. This one means times. This one means f of g of x. Would you please find those two answers? Fg and fog, they're different. And then we'll talk about their domains in a second. Okay, gotta go kind of fast today. So fg is like this. You just have f, and you times it by g. And sadly, some kids think you can distribute into square roots, and you cannot. Do you get? This is your answer, and that's it. Raise your hand if you knew that. Good. If you distributed, somehow remind yourself that's not okay. You can't distribute into that. All right, next up is f of g of x, and I personally start right away by writing it that way. That's, or just a reminder to myself that f ate the g function. So here's the f function, 3 parentheses, and it ate the g function, which is square root of x minus 3, and there's my answer. Can I distribute into that? No. So I'm done. Okay, now let's find the domain of that. Remember how the domain of this is much more complicated than just the 2 number lines overlapping? This one is a formula. Adam, do you remember how it starts? Domain of the inside. Don't whisper it next time, Sam. Domain of the inside. So, intersected with, and then hopefully you can get the rest. Okay, so we came back after the freshman video there, and we have got the domain of the inside intersected with the inside function in the domain of the outside. That's how you do this kind right here, the domains of that kind. And then here was the domain of the inside, and here was the inside function in the domain of the outside, which was right here. That's the domain of the outside function. That's why it says greater than 2. And then I graphed and got the greater than 7 and the greater than or equal to 3, and the final answer was x was greater than 7. Or you could say 7 to infinity. Okay. So what else do we have to know for this test? Well, we've covered a lot of things, one of which is proving 2 things are inverses, and then just finding inverses. All right, so let's find an inverse. I'm going to give you a new set of f of g of x. Here's f of x, and it's going to be 6x squared minus x. I would like you to start with, that's a little too hard. Just take off the minus x. 6x squared. I'd like you to find the inverse of that. And the way they might say that would be f with a little negative 1 of x. Then, I'd like you to figure out the domain and range of the original one and the domain and range of the new one. This is the inverses domain and range. Now, pro tip, hear me, because so many people don't hear this. They think, well, I'm just going to find this and get its domain and range. That doesn't work. You need to find the domain and range of this one. Sometimes when you get this answer and you think you see its domain and range, it's wrong. If you find the domain and range of the original, you just flip-flop them. So the domain becomes the range, and the range becomes the domain. Find the domain and range of the original. If you're like, but I don't know what the range is, draw a picture. Just to sketch a little thing, and you'll be like, oh, I see it now. Once you see the function, you'll know its range. So that's my advice on finding domain and range, is sketch a little picture of it. If you don't know what x squared looks like, then you're like, yeah, you're kind of toast. I'll show you in a minute. Okay, so let's see how you did. This one, you've got a graph that is a parabola. You should know that because it's got an x squared. And it looks like this. Once you see that picture, how do I know it goes through 0, 0? Because I know the y-intercept. Tell me the y-intercept of this. Oh, it's where x equals 0. So right now it says y, f of x is like y, right? Y equals 6x squared. I stick in a 0 for x. I know the y-intercept is 0. Okay? So boom, I know it has to go right there. That's a parabola. And I know its domain is all reals. You could say that with a number line that's filled in. You could say negative infinity to positive infinity. You could say a big R. And the range from, this is important, 0, infinity. 0 has a bracket. because it touches at 0. Okay, now that I know that, domain's all reals and range is 0 to infinity, then I can reverse them. The range becomes the domain. And so the domain's now 0 to infinity. And the range, sorry, the domain here becomes the range, all reals. Okay, so what was this actual function? Well, I'm going to swap x and y. So this was y to start with. So now it's x equals 6y squared. Divide both sides by 6. And then square root. And that brings absolute value of y, which I hope you know means this new thing is not a function. So, because it's got two answers for y. Y equals the square root of x over 6, and y equals the negative square root of x over 6. There we go. There's your two y equals answers. That together makes your inverse. So is the inverse a function? No, because it's got two y equals. So was the original one, this one right here, was that a one-to-one function then? No, because its inverse would have had to also be a function. All right, yes? Yep. There's three different ways I said you could write it, with a number line with everything shaded in, or a big R, or a negative infinity to positive infinity. All of those are okay. All right. So now we've found an inverse. Yay. We found the domain and range of the inverse, which, remember, would you want to find the domain and range of that? Wouldn't that be really complicated? So you don't want to do that. And sometimes it's misleading. You look at that and you can't even get the domain and range from it. But you can always get this thing's domain and range from the original function that you had and its domain and range. So again, if you can't sketch some of the common functions, it's going to really hurt. So let's just go through a few of them. Can you sketch y equals the absolute value of x? Sketch it quick. Do you know it? Just make it in 2 seconds. What if I took the absolute value of x and I did a -1 to it? Now do you know what it looks like? Do you get it's a V shape and it shifted down 1? Raise your hand if you had that one right. Okay, good. You could get domain and range for that pretty easy if you wanted to. Okay. How about square root of x? Do you remember what the square root of x looks like? Could you get domain and range from that? Let's make it -4. Now, do you know what the square root of x -4 looks like? Clearly, we moved it. Do you know where? That seems like left, but it's on the inside, so you don't trust it, so it actually moved right. So it looks kind of like that. Do you get that one has a very distinct domain and range? Okay, yes. Louder. Yep, you could. Okay, so this one, do you get how if this is at, well, we'd actually know. We'd know that this is at 4, 0. Do you get it be pretty easy to tell a domain and range of it? All right, so then would you be able to tell a domain and range of its inverse? Yeah, because of the domain and range here, we just flip-flop them. All right, how about if I gave you the last one here, x to the third. Do you remember what that one looks like? You should have all these parent functions memorized. If you don't know one, it could bite you. Because if you're supposed to find the domain and range, you'll have to have a picture in your head. All right, this one should have looked like this. In this case, the domain is all reals and the range is all reals. Okay. There's only one other one I can think of, and it's 1 over x. Do you remember 1 over x functions? graph. Probably the trickiest domain and range, because it can't be 0 in both the domain and in the range. Okay, so there's the classics, the ones you have to know the domain and range of. Okay, next up is a skill called finding common denominators. Would you just please take this and add 7, but get a common denominator? Okay, first off, you should have said that the denominator was 1. Knowing what the denominator is currently helps a lot. Next, that is the only denominator that really exists. The other one's just a 1. Technically, you times them together to get the new common denominator, so the new common denominator is an x plus 5. You can't go around just multiplying things by x plus 5 but if you do it on the top and the bottom, you're really multiplying by 1. That's what makes it legal. And then on the top, we have 1 plus 7x plus 35 all over x plus 5. And yeah, you should probably put the 35 and the 1 together to make it 36. Raise your hand if you had that one right. Cool, you know common denominators. Next thing, right off top 20 is solving, but this one's more complicated solving. What if you have x equals m over m plus 4, and I want you to solve for m. Solve for m. Okay, your first step should have been to say, if I can factor it, I should, but there's no factoring. So then you go to clearing fractions. And that cancels that. So now it is a little confusing, but just multiply it out and see what you got. xm plus 4x equals m. mx would have been fine too, of course. And then this is important. I'm looking at what do I need to solve for? I need to get m alone. That'll help you. You realize you got to get all the m's to one side then. Now right here, a lot of you would have a tendency to want to subtract the 4x. Don't. Because all you need to do is get the m's on the same side. So subtract xm. Because now look. The m's are on the same side. I may have said x earlier and mistakenly. So back to this. I'm doing it right, but I may have said it wrong. I wanted these to be alone, so I needed to get them onto the same side as each other. Okay, there isn't a way to do that with 2 steps, but I just did it with 1 step. And that's always better. Okay, now I'm getting the m completely alone by, if you can factor it, you should. And the last step, divide both sides so that m is completely alone. I find it helpful to repeat that to myself. Is m alone yet? Oh, nope, m's not alone yet until I get rid of this. And now the m is alone. I can switch the m to the other side if it's an equals. So there we go. You guys may recognize this as part of the solving process if you're finding inverses. But the key here was, do you know how to solve it when there's complicated factoring involved and stuff? Okay. What else do you have to know? Oh, there's so many things in this chapter. So, next one I want to talk about is, let's say that I have got two inverses. I want to prove that they're inverses. So here's two things that I'm going to tell you are inverses. You tell me if I'm really right. We're going to call this one f of x. We're going to call this one g of x. They could mess with you and call them different letters than that, but you're still going to have memorized the formula as f of g of x, etc. Okay, so I'm going to say g of x is x plus 2 over 3. Is that really the inverse? Well, you'll find out. So what is that formula you're supposed to use? F of g of x equals, say it, g of f of x, and they both have to equal x. You are correct. I'm going to draw a line, and they should equal x at the bottom. I don't like to put it up there just because, I don't know, it seems cleaner to me to go like this. Then, you have to have that line down the middle? No, but if you don't, I might have a hard time following your work. If I can't follow your work, you will get it marked wrong. So try to, this one, more than any other problem on the test. It's all about every step of your work. So I strongly encourage you to do this. All right, while you're working on that, a quick reminder, the test is on Thursday. Now, some of you are just going to show up to class on Thursday like normal and no big deal. But there are some people from the middle school, not going to make you raise your hands, but you know who you are. Listen, Sam. If you need to take it not on Thursday, you need to let me know, and I want to talk to you today about what your plan is. You could take it on Wednesday morning in the testing room here at the high school. I could put it in the testing room for you. It would be possible to do that. Number two, you could just come to class like normal on Thursday, but for some of you, you're going to have to get mom or dad to drive you maybe. I don't know. Kind of depends on your scenario. And if you don't want to take it on Thursday and really rather take it Monday, that's okay too. You can come into my classroom, just right here in this room at 7:05 on Monday, and I'd be okay with that too. Okay, so middle schoolers, I'm going to ask you today what your plan is. You're either going to just come to class like normal, or you're going to take it Wednesday morning, that's literally tomorrow morning, or you are going to take it on, and actually for Wednesday morning, yeah, I'll probably have somebody walk you down to the testing room so you got to have a nice quiet place to take it, if you take it Wednesday morning. I don't mean before school, I mean like come to class like normal time on Wednesday. All right, so those are your options. I'll ask the middle school kids later where you want to take it. Okay, so f of g of x. Well, here's f of x, 3 parentheses minus 2. And then g of x is x plus 2 over 3. Now, do you see anything that cancels right away? I do. Careful. If you right here canceled the plus 2 and the minus 2, I would mark it wrong. Yes. Yes. Because this is the only thing that can cancel mathematically. The other one is stuck in a fraction. It can't get canceled until after those 3's get canceled. So the order of you doing this work is really important. And if you had just canceled both and didn't show me any work, like you just have this problem, and you scratched off the 2 and the 3, that will be marked wrong. You can only cancel one thing at a time. Okay, so now these can be canceled. And my answer is just x. Yay. The other side, g of f of x. Do you have to do both sides? Yes. G is empty parentheses plus 2 over 3. What does the g function eat? It eats an f function, which is 3x minus 2. Again, there's only one thing that can mathematically cancel first. Yep, these two, because they're on the top together, they can cancel. Then you'll have 3x over 3. Then the 3's can cancel. Math has an order to it, and the order matters. Now it's x. And if you end with x equals x, then you've done all the steps you need. Because if this side simplifies to x and this side simplifies to x, then clearly they are equal to each other. F of g of x was the same as g of f of x. Okay. Now, if any one of those is too difficult for you, then I would study that topic. We have a worksheet. You have the rest of the hour to work on said worksheet. I'm going to put up a Dropbox for this. I strongly encourage you to do every single problem. And it's not due tomorrow. It's due the day of the test. So you have 2 days to do this worksheet. So be nice to you. What? You should be nice to you. Yeah, because if you save these all for tomorrow night, that's going to hurt because you'll be busy with other things. So I encourage you to do at least half the worksheet tonight. I actually encourage you not to do all of the worksheet tonight because then you would have nothing to practice tomorrow night. I think it'd be really smart to do about half of it. All right? All right. That's all I got for you for the video for today.